we're going to take a look at finding real and complex zeros. This is coming straight from your textbook. We're going to work this problem out. Now notice you've got a graph, and we can see from this graph we have a 0 here at +2. Now, so this is telling us function's graph crosses the x-axis at 2. This is also the x-intercept of the graph. F of 2 equals 0, meaning that when I input a x value of 2 into the function, my output is 0, that's y equals 0, which I would expect because I'm on the x-axis where y equals 0. We can also say 2 is a 0 of the function, and we can also say x minus 2 is a factor of the polynomial. Now notice here they give you the equation, or the function, excuse me. This is a third-degree polynomial. If this is a third-degree polynomial, we should have 3 zeros. We only see one here that manifests as an x-intercept. So that means I can tell by looking at this, yeah, this isn't touching the x-axis. That's because we have imaginary zeros. We're going to have zeros that are in the complex number system. So what we want to do is go ahead and find those complex zeros. So here we go. We were given the function f of x equals x cubed plus x squared minus 3x minus 6, and we know x equals 2. That's one of my zeros. So remember, when you're factoring, you're actually dividing. So we can also use synthetic division here. We also know if 2 is a 0, that means x minus 2 is a factor. So you can do this by choice. You could either do long division using x minus 2, or you could do synthetic division using the 0. So I prefer synthetic division. I find it to be quick and easy. So let's go ahead and do that. I'm going to write down my 2. That's my divisor. Get myself set up for synthetic division. I need my coefficients up here. Now let's make sure that we have all degrees represented. I have a degree of 3, I have a degree of 2, I have a degree of 1, and I have a degree of 0. So I don't need any placeholders. So I'm going to have 1, 1, -3, -6. Okay, let's drop down that first number. We have a 1. Now here we go. Let's multiply. 2 times 1 is 2. Now we add. 1 plus 2 is 3. 2 times 3 is 6. -3 plus 6 is a +3. 2 times 3 is a +6. And when I add those, I get 0, which I should. That's my remainder. And if I already know that this is a factor, I should definitely get a remainder of 0. So now what's left is, this is my degree of 0, that's my constant. Degree of 1, that's my x term. Degree of 2, that is my x squared term. So this is x squared plus 3x plus 3. Okay, now just to reiterate, so now what we have done, we are factoring this. So what I've got so far is x minus 2 times x squared plus 3x plus 3. But I can't easily get a 0 out of this. I need to take another step. Now notice this is not easily factorable. You know, if you look at this, you're thinking, okay, two numbers, when I multiply them, I get 3, and I add them, I get 3. Well, it doesn't exist. So what we need to do is we need to break out our quadratic formula. The quadratic formula will work. Anytime you have a quadratic, you need to find a 0, that's your machine. So I tend to only use it when I come into trickier quadratics that really aren't factorable. So let's go ahead and do that. And again, the reason why this isn't really easily factorable is most likely because it has complex solutions. So let's take a look. If I'm going to do I'm just going to jump right into it. x equals the opposite of b, so that's, here we go, 3, plus or minus the square root of b squared, so that's 3 squared, minus 4 times a, my a is 1, times c, my c is 3, all over 2 times 1. And now we're just going to simplify. X equals negative 3 plus or minus the square root. Okay, this is 9 minus 12. So 9 minus 12 is negative 3, all over 2 times 1 is 2. You need to write that. Okay, so let's just break this down again. I'm going to have negative 3 plus or minus, let's break this down. Okay, you see a negative under the radical, that comes out as an I, the imaginary unit. Square root of 3, we cannot do anything with that. We're going to leave it there. So this is going to be I times the square root of 3 all over 2. Now notice you have two different zeros here. One is going to be the plus, one is going to be the minus. So let's write out our zeros. We have x equals 2. That one was given to us. We also have x equals negative 3 halves plus I times the square root of 3 over 2. I'm just breaking apart this fraction. And we also have x equals negative 3 minus I times the square root of 3 all over 2. And let's do one more. Let's do f of x equals x to the 4th minus 3x squared minus 4. And I'm going to have the zeros x equals negative 2 and x equals 2. So sometimes you're going to divide a few times and you might use different methods. It depends on what you're comfortable with. So I'm looking at this and I'm going straight for the synthetic division. I'm going to start with 0 of negative 2. I need my coefficients. Now notice I'm missing a degree of 3 and a degree of 1, so I need placeholders. So here's my degree of 4 coefficient. I don't have a degree of 3. I'm going to drop in a 0. My second degree coefficient is negative 3. I don't have anything for the degree of 1, so I'm just going to drop in a 0 as a placeholder. And then I have the negative 4. So here we go. Drop down that 1. Negative 2 times 1 is negative 2. Add them, I get negative 2. Negative 2 times negative 2 is a positive 4. Add them, we get 1. Negative 2 times 1, negative 2. Add, we get negative 2. And negative 2 times negative 2 is a positive 4. We add, we get 0, which we should. That's my remainder. Now, if you look at this, this is your degree of 0, degree of 1, degree of 2, degree of 3. Okay, I'm still in a cubic, but I still have this other 0 here. So what I'm going to do is I'm going to divide this again. Now, I'm not going back to the original. I'm taking this factor. So let's grab that 0 of 2, and I'm taking my answer here, my quotient, and I'm going to divide it again. We're just going to keep breaking it down. Bring down the 1. 2 times 1 is 2. That gets me a 0. 2 times 0 is 0. I get a 1 when I add. 2 times 1 is positive 2. And again, I get a remainder of 0, which I am expecting because I was told that this is a 0. If it's a 0, this is a factor. So now again, just to reiterate what we have done, we have f of x equals. So my 0 here was negative 2, so that is x plus 2. times my 0 was a positive 2, so the factor is x minus 2, times here. Now this is your constant, your first degree, that's the x term, there's nothing there, and your x squared term. So this is x squared plus 1. Now, I can, of course, these are the zeros I have. I'm supposed to have 4. There's 2 more. They're going to be in here. So let's just go ahead. We'll use the square root property and get the zeros out of this guy. X squared plus 1 equals 0. Subtract the 1 from both sides. Oops, negative 1. I got to get rid of the square. Take the square root of both sides. Don't forget the plus minus. Times the square root of negative 1. By definition, the square root of negative 1 is I. So x equals plus minus I. And there's 2 solutions there. So my zeros are x equals negative 2, x equals 2, x equals positive I, and x equals negative I.